Jai Hind students, how are you all? I hope you all are staying fit and perfectly healthy and in very jovial mood, right? So welcome back to my YouTube channel. Today we'll be discussing the expression for the distance covered by a body during the last second of its motion. And after deriving this expression, we are supposed to find the solution of these numericals, which are based on equations of motion, the importance of graph, and obviously the topic which we are going to deal in today's lecture. Right, students? So let's start with the theoretical topic first. Let us consider a body to be having uniformly accelerated motion. So what I mean to say is that let us consider a body having motion which is under constant acceleration. So A is constant, right? So suppose A is positive. So as a result, the velocity of the body will keep on increasing at a constant rate. And I am considering the motion to be one-dimensional. That is, the body is assumed to be moving along a same straight path, right? Either it is falling along a same straight line, or it is moving along a same straight track, right? So let me first illustrate what's the purpose or what are we supposed to find the expression for. Suppose this is the origin and the body is at this particular point. Here the initial velocity is u. Let us consider the initial velocity of the body to be u, right? After t equals to 1 seconds, suppose the body is at this point. After 2 seconds, t equals to 2 seconds, suppose the body is at this particular position. Since the body is having uniformly accelerated motion and A, let us assume it to be positive. So it means that the velocity of the body will keep on increasing at a constant rate. So in the first second, it has covered this distance. In the second second, it has covered much larger distance. In the third second, it will cover still larger distance. And so on. Per unit time, it will tend to cover more and more distance with the passage of time because it is under constant acceleration. Acceleration means the velocity changing, right? In this case, in magnitude. And since acceleration is constant, so it is changing at a constant rate. Here I have considered the velocity to be increasing at a constant rate. So per unit time, the body will cover more and more distance. So this is the distance covered by the body during the first second, this is the distance covered by the body during the second, and this is the distance covered by the body during the third second. Understood? So suppose S3, it is the distance covered by the body during 3 seconds. This is S2. It is the distance covered by the body from point O in 2 seconds. So S2 and S3 are the distance covered by the body during 2 seconds and during 3 seconds respectively. So students, what will be the distance covered by the body during the third second? So during third second, the body has covered this distance, isn't it? So this is the distance covered by the body during third second. So S third, it will be equal to S3 minus S2. So this is a simple illustration. So our objective is to find out this expression, isn't it? Suppose the body covers this distance OC in time 3 seconds. So it is taken 3 seconds to complete its journey. So we need to find out the distance covered by the body during the last second of its motion. Here the last second is the third second of its motion. So the distance covered by the body during the third second of its motion would be S3, which is the distance covered by the body during 3 seconds, minus the distance covered by the body during 2 seconds. So in this case, S third, it will be equal to S3 minus S2. I hope you have understood this concept. So this is the expression which we need to find, right? So what we'll do is, we'll generalize it. What we'll do is, we'll consider the body to be covering a certain given distance in n seconds. n second is the time taken by the body to complete a certain distance when it is moving uniformly accelerated, right? So our objective will be to find out the distance covered by the body during the nth second of its motion. Nth second, that is the last second of its motion. So that is our objective. Expression for the distance covered by a body during the last second of its motion. And remember students, here we are considering the body to be having uniformly accelerated motion, right? Okay, so let's generalize it. Suppose this is the origin, the body is at point O and having initial velocity u, right? And the body is to cover distance OB, right? And it is covering the entire distance in n seconds. So the body is taking n seconds to complete its journey from O to B. In time n minus 1 second, right? In time n minus 1 second, the body will be somewhere over here, isn't it? So OB is the distance covered by the body during n seconds. N is the total time taken by the body to complete the entire journey from O to B, right? So Sn minus 1 may be considered to be the distance covered by the body during n minus 1 seconds. If n is 3, then this will be 2, right? So this is the distance covered by the body in 3 seconds, this is the distance covered by the body in 2 seconds, right? So we have generalized it into n seconds and n minus 1 seconds. So n second is the total time taken by the body to complete the entire journey. So what will be the distance covered by the body during the last second, that is nth second of its motion? So it will be this one. This is Snth. Students, try to differentiate between these two. Sn is the distance covered by the body during n seconds. This is the total distance covered by the body during n seconds. And Snth is the distance covered by the body during the last second of its motion. Nth, last second of its motion. So from the diagram it's pretty clear. Sn is equal to Sn minus Sn minus 1. So I'm simply generalized it. So now let's substitute the value and let's try to get the expression. What is Sn, students? Total distance covered by the body during time n seconds. We can make use of the second equation of motion. S equals to ut plus half at square. So I'll be making use of this equation. S equals to ut plus half a t square. So Sn, t is n seconds. So we'll get un plus half, a is constant, t square. So total time is n, so it will be n square. Minus Sn minus 1. So here in place of t, I must write n minus 1. So it will be u, in place of t I must write n minus 1 plus half, a, in place of t I must write n minus 1. Right, students? Let's solve it. So it will be un plus half an square minus un minus u plus half a n square minus 2n plus 1. Keep solving it. So what you get is un, this minus un get cancelled, isn't it? So half an square, it will become an square. Let's solve it. Un minus un get cancelled. We will be left with half an square minus plus u, then again minus half an square minus plus. We will get an, isn't it? And then minus, it will be a by 2. So half an square minus half an square will also get cancelled. So we are left with u plus a by 2 can be taken as common. Over here it will be 2n, isn't it? Minus 1. So students, this is the formula for the distance covered by a body during the last second of its motion. And it is Snth is equal to u plus a by 2 in bracket 2n minus 1. N is the total time taken by the body to complete its journey. And the body is in uniformly accelerated motion. So this is a very important formula. Right, students? So now we are in a position to solve certain questions based on this particular formula. Right? Let's attempt one by one. Okay. So let's start with these two questions first. Let's attempt third question, fourth question, or let's attempt the questions in the reverse order. Right? So let's attempt question number 4 first. Because the last two questions are based on this particular formula which we have just now derived. So let's start with question number 4. Let's do it in the reverse order. So the fourth question is, a body covers 4 meter in third second and 12 meter in fifth second. If the motion is uniformly accelerated, how far will it travel in the next 3 seconds? Okay. So what we'll do is, let's write down the given information, right? So body covers 4 meter in third second. So it is given S third is equal to 4 in meters. Then it is given S fifth. The body covers 12 meter in the fifth seconds. This is given. It's in meters, right? And it is uniformly accelerated. So what's the formula to be used? Distance covered by the body during the last second of its motion. It is u plus a by 2, 2n minus 1. So this is the master formula over here. Okay. Now S third. Let's consider the first equation. Let's say initial velocity be u, acceleration be a. So 2 in place of n, substitute as 3 minus 1. So what you get is S third is given to be 4. So the first equation will be 4 is equal to u plus a by 2, 6 minus 1, that is 5. Put this as equation number 1. Right, students? Similarly, the second information, the body is covering 12 meter in the fifth second, not in 5 seconds, in the fifth second of its motion. So S fifth, it will be equal to u plus a by 2, 2 in place of n, it will be 5 minus 1. So what do we get is S fifth is given to be 12. So it will be equal to u plus a by 2, 5 to the 10 minus 1, that will give us 9. Now look, these are the two variables. There are two equations, so we can easily solve it to get the value of u as well as a. So let's solve it. Now if you subtract these two, first minus second, what we get is 4 minus 12, that will give us minus 8. U minus u will get cancelled out. So over here it will be 5a by 2 minus 9a by 2. So what you get is minus 8 is equal to, so it will give us minus 4a by 2. Isn't it? Minus get cancelled. So we are left with 8 is equal to 2a, which implies that a is equal to 4 meter per second square. So students, we are able to get the acceleration. So it is obtained to be 4 meter per second square. Right? Now what we are supposed to do is substitute this value of a in either of these two equations. Substitute this value of a in either of these two equations, in equation 1 or equation 2, and we can get the value of e. So from first, what we get is 4 is equal to u plus a is 4. So 4 by 2 multiplied by 5. So 4 is equal to u plus, so u would be equal to minus 6 meter per second. So students, we obtained both the initial velocity as well as the acceleration. Right? Now let's consider the question once again. How far will it travel in the next 3 seconds? So I'll illustrate it diagrammatically, what we are supposed to find. So a as well as u, these two values we have obtained, the initial velocity of the body and the initial velocity as well as the constant acceleration. Now look, as per the question, what we are supposed to find is, okay, this is the origin, third second. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is time, suppose. Right? Let us consider the body after 3 seconds. Look, we are supposed to find out the distance covered by the body in the next 3 seconds. Means after 5th second. After 5th second in the next 3 seconds. This is to be calculated. After 5th second in the next 3 seconds, what's the distance covered? So, will it be given by this? This is the distance covered by the body during 8 seconds. This will be the distance covered by the body during 5 seconds. So S8 minus S5, that will give us the distance covered by the body in the next 3 seconds. Clear, students? So required distance, that is the distance covered by the body in the next 3 seconds after 5 seconds, right? It will be given by distance covered by the body in 8 seconds minus distance covered by the body in 5 seconds. Now, second equation of motion is to be used. Formula is S equals to ut plus half at square. It is not S8th, it is not S5th, it is S8 and S5. S8 suggests the distance covered by the body during 8 seconds. S5 suggests the distance covered by the body during 5 seconds. Right? So after 5 seconds, for the next 3 seconds, the distance covered by the body would be given by this. Okay, S8, it will be ut plus half at square. U is minus 6. T is 8 plus half. A is 4. And T square is 8 square. Right? It is S8. Minus S5. S5 can be similarly obtained. It is ut. U is minus 6. T is 5 plus half. A is 4. And T square, that is 5 square. Okay, let's solve that. So it will be minus 48 plus 64 into 2, 128. Right? Minus, it will give us minus 30 plus 25 and 2, 50. So that will in turn give us, it will be 80 minus 50 minus 30, that will give us 20. So it will be equal to 60 meters. So students, after 5 seconds, the body will cover a distance of 60 meters in the next 3 seconds. So that is done. So this question was very, very good question based on the distance covered by the body during the last second of its motion. And here obviously we have also made use of the equations of motion, particularly the second one, displacement time relationship, right? Okay, now let's attempt the third question. Third question is, again, based on the distance covered by the body during the last second of its motion. Okay, a stone let fall from the top of a tower traverses a distance of 24.5 meters in the last seconds of its fall. Okay, this is a tower. Suppose from here a stone is made to fall freely. So initial velocity is 0. And suppose it is taking n seconds to reach the ground. Total n seconds, right? So this can be considered to be n minus 1 seconds. So this is the distance covered by the body during the last second of its motion, and it's given to be 24.5 meters. So what I've considered is, if the body has covered the entire distance in n seconds, then Snth is given. That is the distance covered by the body during the nth, which is the last second of its motion, is given to be 24.5 meters. We are supposed to find out the height of the tower. This is to be found. This is to be found. Now look, we are aware of the formula for the distance covered by the body during the last second of its motion. So what's the formula? Snth is equal to u plus a by 2, 2l minus 1. This is the formula to be used, right? Snth, last second, the body has covered a distance of 24.5 meters. U, free fall of a body, initial velocity is 0. A, out of the influence of gravity, so G is positive, plus 9.8. divided by 2, and this is 2n minus 1. We can easily solve it. 24.5 is equal to 4.9, 2n minus 1. Or students, we can write 2n minus 1 is equal to 24.5 divided by 4.9. So it will be equal to 5. So 2n is equal to 5 plus 1. So 2n is equal to 6, which implies that n is equal to 3. So the total time taken by the body to reach the ground from the top of the tower is 3 seconds. Now what we are supposed to do is, we are supposed to find out the height of the tower. Now height of the tower, we have to consider the motion from this point to this point. So let's consider the second equation of motion. Because this displacement is to be found. So in place of s, the total distance covered by the body during 3 seconds is h. U is 0. Half a is to be considered as plus g, 9.8 meter per second square. Total time taken is 3 seconds. So it will be 3 square. So what you get is 4.9 multiplied by 9. So it will give us 44.1 meter. So this is the answer, students. This is the height of the tower. Right, students? Again, a very, very interesting question, isn't it? So we are over with question number 3 as well. So question number 3, 4 based on this particular formula. Right? Okay, the second one, graphical question. Again, it's pretty important, pretty good one. So let's discuss question number 2. So question number 2 is, the VT graph of a body moving along a fixed direction is given. Obtain the distance traversed by the particle between t equals to 2 to t equals to 6 seconds. Okay. Students, remember, significance of VT graph. The slope of VT graph will give us acceleration. Secondly, the area under VT graph, that will give us distance covered, isn't it? So what to do is, let me draw this graph over here. This is the graph, it's given. I think this is given to be 5 seconds, this is 0, and this is 10. This is time in seconds. And this velocity is given to be 12 meter per second, its velocity, right? So we are supposed to find out the distance traversed by the particle between t equals to 2 to t equals to 6 seconds. Suppose t equals to 2 is over here and t equals to 6 is over here. So drop a perpendicular like this. So what we are supposed to do is area under the curve from t equals 2 to t equals to 6 seconds. That will give us the answer. That will give us the distance covered by the body between these two given intervals of time. So let us divide it into 2 parts. This is the first figure. This is the second figure, right? This is a trapezium and this is another trapezium. So basically area of 1 plus area of 2. This is area 1. This is the first area, which is a trapezium, and this is the second area, which is again a trapezium. So required distance covered by the body would be equal to area of first portion plus area of second portion. And students, the formula for the area of a trapezium is half sum of the parallel sides multiplied by the distance between them. So the coordinates, this is 2 and this is unknown. This we are not aware. Here the coordinates are 5 and 12. Here the coordinates are 6 and again unknown. And here the coordinates are 10 and 0. Am I clear, students? Okay. In order to find out the area of this trapezium, we need to find out this coordinates, right? Let us consider it to be m and let us consider it to be n. Now look, this is a straight line. And students, in the case of a straight line, the slope is always constant. Slope is y2 minus y1 divided by x2 minus x1, isn't it? So, from O to A, let's find out the slope. Between these 2 points, the slope is m minus 0 divided by 2 minus 0. M minus 0 divided by 2 minus 0. And between these 2 points, again same straight line, so the slope would be constant. So it will be equal to 12 minus 0 divided by 5 minus 0. So m by 2 is equal to 12 by 5. Isn't it? M by 2 is equal to 12 by 5. So m would be equal to 24 by 5. That is 4.8. So we have determined the value of m. It is 4.8. Clear, students? We obtained the value of m. Similarly, consider this line. Again, the slope would be same. So what to do is, we can consider the slope between these 2 points and these 2 points. Or between these 2 points and these 2 points. It's your wish. So, between these 2 points, what will be the slope? It will be 0 minus 12. This is x1, y1, this is x2, y2. So, y2 minus y1 divided by x2 minus x1. So, 10 minus 5. It will be equal to same slope. Slope of a straight line is constant. So, we can consider these 2 points as well. So, 0 minus n divided by 10 minus 6. Right, students? So, let's try to solve it. So, minus 12 divided by 5 is equal to minus n divided by 4. Minus minus get cancelled. So, what we get is n is equal to 48 by 5. So, it will be 9.6. So, the value of n is also determined. Clear, students? Now we are in a position to find out the area of 1 and 2. Right? So, distance covered. Let's find out the distance covered now. It is equal to area of the first one. Half sum of the parallel sides. These are the 2 parallel sides. This has got the dimensions of m, that is 4.8. Plus this parallel side has the dimensions of 12. Multiplied by the distance between them. What's the distance between them? It is 3 units. Multiplied by 3. Right? Plus area of the second portion, this one. Again, half into sum of the parallel sides. One of it is 12. The other parallel side has got the dimension of n, and n is 9.6. Multiplied by the distance between them, it is 1 unit. Right, students? So, on solving, what we get is half multiplied by 16.8 multiplied by 3. Right? Plus half, this is 9.6 multiplied by 12 plus 9.6, that is 21.6 into 1. It will give us the same value. So that will give us 8.4 multiplied by 3 plus 10.8, isn't it? So on solving, what we get is 25.2 plus 10.8. That will give us 36 meters. So students, this is the answer. The distance traversed by the particle between the time interval t equals to 2 to t equals to 6 seconds is 36 meters. Right? It is given by the area of the shaded portion. So, what concept we have made use of over here is the area under VT graph gives the distance covered by the body between the 2 given intervals of time. Right, friends? Okay, so second question is also done. We are left with the first question. So let's try to attempt the first question now. First question is relatively very simple. The VT graph of 2 objects makes angles of 30 degree and 60 degree with time axis. This is V, this is T. One is making an angle of 30 degree. This is the first one, and this is suppose the second one. First one is making an angle of 30 degree. Second one is making an angle of 60 degree with the time axis. Find the ratio of their acceleration. Now students, point to be noted is that slope of VT graph, that will give us acceleration. So we are supposed to find out the ratio of the acceleration of the 2 bodies. So slope of VT graph will give us acceleration, and slope is given by tan. So students, tan theta, it's y2 minus y1 divided by x2 minus x1, right? So slope of VT graph will give us tan theta, which in turn will give us acceleration. So the ratio of the acceleration of the two bodies would be given by tan theta 1 divided by tan theta 2. So in the case of first body, the graph, that's the straight line, is inclined at an angle of 30 degree with the time axis. So theta 1 is 30 degree. So it will be tan 30 degree. And in the second scenario, second case, the graph makes an angle of 60 degree with the horizontal axis, which represents the time. So it will be tan 60 degree. So the ratio of the acceleration of the two bodies would be given by tan 30 is 1 by root 3, tan 60 degree is root 3. So we'll get 1 by 3. So students, this question was relatively simple, which makes use of the concept that the slope of VT graph will give us acceleration. And in this case, the ratio of the acceleration of the two bodies is found to be 1 by 3, right? So students, I hope you have thoroughly enjoyed this session and understood the concepts involved in each of these questions, right? So that's it for this session, and hopefully you will practice more and more questions. So do take very good care of yourself, and we'll continue in the next session then. Till then, goodbye, and be safe and take very good care of yourself. Thank you.